Hi, everybody.
Hi, everyone.
Hi.
That's nice.
Yeah, good stuff. Welcome. All right, good stuff. So my name is Josh.
But you're pointing at me.
Well, and more importantly,
I'm Alina. Hi.
Yeah.
Nice to see you all here.
yeah, there you go. That's what I'm saying. Like I was getting my nonsense out of the way very quickly, so we can move on to the star. Look, this is a talk. It's gonna be. We're gonna go through some mind-bending stuff. It's gonna be a lot of fun. I couldn't have done it without my friend here, Alina from the GraalVM team. We're gonna be looking at the intersection of GraalVM and Spring. How many of you are using Spring? Good.
And GraalVM?
What?
Hey.
Okay,
we are on a mission to change this after today.
Yeah, you're in the right place. This is the first time we've done this thing. Hopefully, it's going to be fine. Actually, the important thing that you need to know is like 5 minutes into the talk. After that,
you can leave.
it's just, yeah, it's all just extra from there, okay? So good. Don't leave. I mean, you could, but
please don't. But the most important stuff will be 5 minutes.
Right.
So if we can get your attention for 5 minutes, that would be perfect.
Right. So that's her on the
Twitter, the
Twitter,
bird side?
the bird side, and then that's me. I've got a YouTube channel. It's not great, but it's a thing. There's also the code. So if you want to play the home game, follow along at home, grab the bits there. There's even like there's a README there, like a detailed sort of annotated README with all the good stuff there. So yeah, good stuff. Okay, let's just get the basic stuff out of the way. How many of you were here when I did introduce Spring Boot 3.x just a couple of days ago?
Me too.
Okay, so no refunds, none. Yeah, good. So most of you are here. Good. So you saw that there's like the happy path works. Let's just go ahead and review that and be on the same page here. Whoa.
So going to the Josh's happy place, right? Yeah. Start with Spring.io.
Right. New project. We're using Maven.
Are you okay with us using Maven? Is Maven fine?
Yeah.
Let's do it.
Actually, who's using Maven? Okay.
More than fine.
Who's using Gradle? Oh,
okay.
That's about 50-50, I'd say.
You'll make my colleague Cedric very, very happy. I'll pass this to him.
Okay, good. So, Bootiful AOT. We're going to build just a stock standard just to get this regular kind of thing done, and we'll quickly move into the details here. But this is just a regular application. The only thing you need to know is that you need to use GraalVM, right? You need to actually opt in to the GraalVM native image support. No big deal. Just type in GRAA, and it'll do the rest for you. By the way, there's Command B, right? Command B, and you get that. Okay, so we're going to hit generate, open this up in the IDE, just to see that it's working, just to get the happy path sort of case going. Okay, reload. Here we are. Come on. So, AOT application. The goal here, just very stock standard Spring application. You've seen me do something like this before. We're just going to have an application that writes data to the database. We're not going to linger too very long in the details here. I just want you to see that this is possible. It's the normal kind of thing that you would expect. It's a GraalVM without compromise, right? So there you go, basic repository, just a simple hello world Spring application that has some data in the database. So data.sql, so insert into customer name values. Let's say Alina. And yours truly, hello. And then we've got this.
We need some more names.
Yeah, good idea. Let me create the schema, and then we can think about the names. ID, serial, primary key. So this is a text file that's in the source main resources folder. And just keep that in mind for later. That's going to be quite interesting. So there's that. Schema, what other names do we want? So we got people in the GraalVM team, Thomas. We've got Stefan on the Spring team. Also, we got a different Stefan on the DevOps team right near here. So we've got who else? Oh, Sebastian. I get to use the accent twice in one day. That's a good day. We've got Jurgen, right? This is another one. And I think, so weird, funny thing. Both this person, Thomas. How do you pronounce the last name?
Würtinger.
How do you pronounce the last name?
Würtinger.
Bless you. How do you say the last name? Oh, I don't know. Okay, so anyway, that name, that person, and this last name, and this person are both from Linz in Austria, which is cool. Small world. Okay, so good. There's 6 names. Give me some other names on the.
Fabio. How can you forget about your favorite doctor?
one of my favorite, yeah, top five. Fabio Niephaus, yeah?
Niephaus, yeah.
Is that how you pronounce it, by the way?
Yes, it is.
Did you ask? Because I don't know. I don't want to get it wrong.
I
again.
asked, and it's right. All good. Okay, I think we're good with the names.
But 7.
Okay, one. Suggest as a name.
Yeah. Oh, Tiffany. Okay.
Tiffany. Let's do it.
There we are. Good. Okay, good. So there's just regular thing, not special, just a regular Spring Boot app. I'm just running it as we go here. Return new application. Okay, and we're going to use this repository, r.findall.for each system out print line. Okay, good. And what else? I guess a regular HTTP controller using Spring and the servlet API or the reactive support there. So, either thing works just fine. Again, stock standard stuff. Looks like anything you've written in the last several years using Spring. That's the whole point, people, is that for a good many use cases here, this is just going to work as you expect, okay?
No black magic yet, no configuration. This will all just work. Black magic will come later.
Exactly. So here we go. Restart. Go to the browser. Localhost customers. That's working in the JVM.
Perfect.
Fantastic. Let's make it work in the
Native
GraalVM.
mode.
And this is the thing. We didn't have to do anything to the build at this point to make this work, but we are going to create a file here. So touch build.sh because we're using Maven, and I don't want to have to remember this each time. So build that.
And we already built this many times, so we just want to use the script to make this a bit faster for ourselves.
Maven -p native, activate the profile. And then
compile.
Clean native : compile. Compile. And if you're using Gradle, you would do Gradle w native compile. Okay?
I think you wanted to remove target each time, no?
Yeah, clean. No rabbits up my sleeve, okay? Okay, good. So, chmod x build.
Can we also add the quick build mode?
The what?
Quick build mode for native
Oh, right.
image.
So we want to optimize our builds. There are ways you can make your, this is the thing. The GraalVM native image compilation does a analysis of all your code and all the classes in the class path. And so the larger the class path, the more time it takes. In my case, I've got a very small application, so it doesn't take that much time. But if you get like a non-toy app, it can start to be a thing. So what we're going to do is we're going to use configuration here. And what is it? Build args. Yep. Okay, so oops, for this one, isn't it? Yeah. Configuration, build args, build arg dash z, capital O, B. Okay, and then get rid of this.
So as Josh is typing, so what this will do, this will speed up the compilation phase of the build process. So not the whole build process, but at least the compilation phase. And it will skip some of the optimizations. So at the runtime, the app wouldn't be so fast. So we are not optimizing for the full performance. But if you want to get faster builds, so just we can get faster feedback loop, this is very helpful because this will speed up the compilation phase of our build. So as you can see here, we are showing the warning that you use this flag. This will make the build process faster. But please, when you go to production, remove this so you can get peak throughput at runtime.
Right.
OK, we are all set.
It's also in purple, which is nice. OK, hold on.
I like the color as well.
You don't get to see purple a lot in the command line these days. I'm just saying it's an underserved color.
That's why the native image build output is so pretty. Look at that.
Yeah. Anybody here using cyan on purpose? In anything in their...
You should do it more.
Yeah. OK. Anyway, this will take a minute. It just does. I don't know. Like we had a whole...
That's a lot of work, right? So look at that. We are taking a whole Java application, all of its dependencies. We are analyzing all of that at compile time to produce that native executable. So you can give this to the native image that is doing not a trivial job, and it needs some time to do it, right?
It's taking... Wait, no, it's because it's gone. Oh, yeah, OK. It's finished, no wonder.
Yeah, let's run. Let's see what it does.
So there you go, target, AOT. OK, there we go, right? There's the application. Good, fast, nice. Look at the process identifier. Here we are.
Yep.
PS-O, RSS, this thing, right? So 100 megs of RAM. Good, OK? That's the whole point. That's the experience that we expect you will have if you're able to make the jump to Spring Boot 3. When you make the jump to Spring Boot 3, barring any weirdness with moving to a new version of Java, that shouldn't be that hard because, again, Java's got, it's just famously very good and backwards compatible. And of course, if you have any Jakarta EE types that need to be accounted for because you had Java EE types before, that'll be a thing. But basically, moving to Spring Boot 3 is pretty easy. If you can do that, the goal here, the out-of-the-box experience that we're hoping for on the Spring team and in conjunction with the GraalVM team, is that just a large majority of apps just work. It's not going to always be the case, and that's, I guess, the rest of our talk is sort of what happens when that's not the case.
Right. So those were the actual 5 minutes we mentioned in the beginning. For most of you, hopefully, for most of the cases, you will do just what we did right now. So you start your project, you add your code, you add your dependencies, you add GraalVM native image as a dependency, and it just works.
Right.
So that would be too easy, right? So now we will switch into the black magic and complicated stuff. And the rest is just for the cases when you hit those corner cases and maybe some things wouldn't work out of the box.
Right.
So we will show you all the things, how they are happening in the behind the scenes.
And this reminds us of a famous quote or a comment in Unix, System 6, from a long time ago, which is, you're not expected to understand this.
Can we show it maybe quickly?
Yeah, show the what?
Show the meme.
Oh, yeah, sure. So let's go to, what is it, web.archive.
That's a lot of typing.
I'm just going to, okay, good. So this is a great comment, and it's not the challenge that it sounds like. It's not suggesting, you're not smart enough to understand it.
You just don't have to, right?
It's not going to be on the test. That's the point. Most of this you don't need to know. It's not going to be on the test. You're not expected to understand this for the test, okay? That's what the comment is. But it's in this code right here, right? So if the new process paused because it was swapped out, I can't read it anyway. Okay, it hurts my head. So you're not expected to understand it. Fair. That's kind of the territory we're now entering. We're in the intermediate phase of this is not going to be on the test. You don't really need to know this for 90% of the use cases, right? And as we move further along in this talk, the things we talk about at the very end are going to be on significantly fewer corner cases, right? You'll encounter even less than this, okay? So this is Dennis Ritchie talking about what the comment meant in the code. It wasn't him who wrote the comment. It's just him explaining what the origin of it, right? So you are not expected to understand that. Just repeat after me, okay? Very important.
So this will be the tagline for the rest of the talk. We will show you some stuff that maybe you don't necessarily have to know, but it's cool to show, and we can, so why not?
Right. First things first. There are some dynamic behaviors, right?
So as Josh calls them, all the fun things in Java, right? So things like reflection, serialization, proxy usage, right? And that poses a bit of a challenge for GraalVM native image, because probably we should have mentioned this in the beginning, but the way native image and GraalVM performs this ahead-of-time compilation of Java programs happens ahead of time at the compile time, right? And it happens under a closed world assumption, so everything there is to know about your application needs to be known at the image build time. There could be no random unknown behavior at runtime, because this whole compilation happens at build time. And the reason why we do it at build time is to remove all those expensive, heavy lifting operations from the runtime to build time, so you can do them once and not have to do them every time when you start your application. But as you can imagine, operating under closed world assumption poses a challenge to those dynamic Java features. And there are multiple ways to make them work, and we will show you how to make it happen in very many different ways. We just hope that you would never have to do this manually, but just for fun, and because we can, we will show you how to make those dynamic features work with Java.
Right.
And the first thing we want to show you is how you work with resources if you want to run your application in the native image mode.
Right, and so just to reiterate, earlier on, we have some resources here in source main resources. Got application.properties, got data.sql, schema.sql. These are well-known things, but generally, you can't rely on everything being where you expect it to be. So I'm going to say, I'm going to have a message here, and, hi, Mom. Okay, there you go. So we've got this message right there, okay? And we're going to just load it on the JVM. Pretty simple stuff, stock, standard, simple stuff. And even that failed.
Not that simple, apparently.
Let me see, what did I do?
What's up?
Oh, it's the old, I took out the dependencies. So I have to recycle the build. Do I still have the imports? No, I shouldn't. Okay, web server already running. Oh, because I started the native image somewhere?
No, this is not, okay.
There we are. Take 3. Fantastic. Wait.
So it took us only a while to make it work on the JVM. Now let's try native, because how hard can that be?
But why is it starting as a web app if I got rid of the web? IntelliJ hasn't synced up the class path here. Okay. Okay.
What's the annotation
refresh.
we used for the?
Just refreshing. Got to refresh. This is like a fun thing. There you go. There you go. So it starts up and spins up and spins down. No big deal. Okay. Let's turn that into a native image, right? And we've got our little shell script here. And this, again, if you saw our talk my talk 2 days ago, you know, this thing can just take enough time that it's distracting. And so rather than sit here and suffer the indignity of like waiting, we have prepared some random facts.
About GraalVM.
Yeah, right. So first things first, did you know you can use UPX, not UPS?
UPX. Anyone ever used UPX?
Right.
Okay, I guess it's not that common in the Java community because it works with native image, like native apps primarily, right? But what it can do, it can compress your image even further as a native executable. So maybe you are running in a resources-constrained environment, and you need to reduce packaging size as much as possible. So you can take UPX and compress native executable to take the size even further below, and you can even choose different compression levels.
Right. It's pretty good. So, and there's this just
amazing
wonderful
talk by my colleague Sean Smith, and there he shows how you can take a Java app to a container size as low as 5 megabytes. So if you want to check it out, go to YouTube, find it there.
It's from that other DevOps. It's, you know, sure, it's fine. OK, so yeah, good. 33 seconds.
Not bad.
Fine, right?
Should we just add to our build script running the app after we are done?
Yeah, OK, smart. Really smart. Here we go. So, and target
AOT.
Come on. I'm typing at an angle here, people. It's not easy. OK, good. So AOT. It failed. Of course it failed, right?
But we expected that to fail, right?
Right. So we knew that's going to fail. How do we fix this? What's the easiest way to fix this? Well, from the GraalVM perspective,
I mean, not an easy, but let's start there, right? So one thing you can do is you can provide a configuration for this app to let native image know that you will be accessing that resource at runtime. And for that, you need to tell native image what exactly you will be accessing and where the file is, because the runtime hasn't happened yet, right? We are still in the build time phase. So you need to know, you need to tell native image what will be happening at runtime and what exactly you need at runtime. So for that, we can write this little configuration piece in one of our favorite formats, which is JSON. And should we here figure out how do we pronounce JSON?
Right. OK. I'm on a quest. I'm trying to figure this out.
OK, so we were arguing earlier today with Josh, how do you pronounce JSON? And we have two versions. One is JSON, and the other one is JSON. So let's maybe vote together which one is the right one. So is it JSON?
OK. So any French people here?
French is Josh's second favorite language, apparently. So he feels very sad about this.
Yeah.
And JSON? I guess JSON it is. I'm sorry.
JSON. So includes.
So as Josh writes this beautiful JSON, this is how we would tell native image to make this resource discoverable for the build. And if we made YAML, right, because, you know, it's so easy to make YAML, right?
Not in Play Company.
Yep.
So we've got this directory structure, right?
Right.
On the class path. We can do that for our code, but other people can put it in their libraries as well, and GraalVM will find them all and integrate it into the sort of the whole compilation. OK, good.
So let's try, and let's hope it works. And should we go back to our random facts?
Yes. OK, static. So this is the other thing that just I don't think really people have gotten to appreciating just yet, which is that you can build statically linked, or mostly statically linked, native executables using GraalVM. So we're building an application, right? And we're using Spring and all this good stuff. But you can actually build a DLL or a .dylib or .so using GraalVM, which you can then link to from like your Swift iOS code or your Windows desktop app or whatever, right? I mean, there's some, or your Go code in theory. I mean, there's some really uncanny possibilities here, friends. And we're not going to do that. I don't want to like summon the seventh seal of the apocalypse by trying to do that on this machine, but you could, right? Like, it's just an amazing possibility.
There's a lot of stuff you can do with GraalVM. Yeah. So what's up with our build?
There we go. It worked. Okay?
So we build it and we run it because now our build script also runs the produce executables. We get our hi mom message. Excellent.
Right.
We write that resource at runtime.
Right. Another use case. Reflection.
Reflection.
Our friend
OK,
reflection.
How many people here have heard that GraalVM doesn't support reflection? OK, so fewer, you know, it gets better, but still many people are under the impression that GraalVM doesn't support reflection. And that is not true. GraalVM works with reflection, but there are things to know about it. So reflection itself is very dynamic, as you can tell, right? So again, for native image, there is no way of knowing where exactly will be happening in terms of reflection at runtime. But again, a good thing is that there are ways to solve this. So one is that more or less predictable, reasonable calls to the reflection API, native image will figure out on its own, and we will show this to you in a bit. So some reflective calls would work out of the box without any configuration needed from your side. Some things that are harder to predict, so maybe less obvious, will be harder to figure out for native image, and for that, you would need to provide config. And there are multiple ways in how that config can occur. So that config can be coming from a file called reflect config.json, so similarly how to be had for resources. Or one thing more you can do is that writing JSON files is not that exciting, right? So what you can do is you can use the tracing agent that native image comes with. What is happening there? OK. So you can also use the tracing agent the native image comes with, and that agent will observe your application behavior at runtime and will produce the configuration for you automatically, so you don't need to do all that manual work. So are we doing the agent yet?
We're going to run the broken one, I suppose.
OK. Well, I mean, not entirely broken.
Do you want to just like, well, yeah, it's true. It'll get halfway. You want to just skip ahead and we can just assume it's broken, or should we show them the broke?
Let's show how it works at this time.
OK, well, this is a little awkward. We're like 15 seconds into it. I don't want to start a fact for another just 15 seconds. That's a waste of good fact.
It will not take that much time, but let's see how long it takes.
I want those facts for later.
So, OK, what do you think? Will this app work or not? Even Josh is not so sure, as you can tell, right? No. OK, let's see what happens. So here's the first point we want to make, right? So got the class? Yes, we got the class name, and this was resolved by native image on its own, right? This wasn't configured by us. But later on, when we try to get constructors, it gets more challenging, right?
Yeah, a lot more challenging. So we want to be able to create that configuration. Last time we just did it by hand.
But it wasn't fun.
It's not how I'd spend my Saturday, no. OK, so what do we do? What's the best way forward?
So let's use the tracing agent and see if it can look at our app, figure out this call, and provide the config for us. Okay. So for that, we'll go back to our POM.xml, and we will enable the tracing agent over here.
And I don't know why this is the case. It just is. We're doing this in the Spring Boot plugin, not the native image plugin.
Yes, because we can. I mean, we can also do it from the native Maven plugin, so it also has support for the tracing agent. But since this is a Spring Boot app, it just makes more sense to do it from Spring Boot.
Oh, my goodness. I am native out. OK. Config
this is
output.
A lot of typing for the last day of the conference.
Target.
So what we are telling here is we want to run with the tracing agent, and we want to put the config in this specific file and then use it.
OK. So we're going to run this program. It's got this agent attached to it. I think I'm not sure if that's a dash or whatever.
Oh my God, about the JSON thing in the config. So but why do I feel that this will break? But let's see.
If this is what breaks it, well, we deserve it. OK, good. So I ran the program. That's all I did. So I just ran it on the JVM, not as a native image, right? And that should have given us this folder called JSON.
Amazing.
OK. And here's this. And you can see it's already generated the config for what we need to do, right? For everything, right? And so we don't need everything. Most of it will be provided by the
Because that was happening on the JVM, right? So
we
don't need all those reflective things necessarily on native image. So we just want to find config for one specific part that we want to make discoverable about native image, and that is our album class.
Right. So reflect-config.json. And then we go here to resource config. Nope, which one?
Reflect config.
Oh, down here. But what is is it just a bracket? Yeah, it's just square brackets. OK, so go here to, oh, I'm getting confused. Reflect config, this one.
Yes.
OK, so it's going to tell us we want to do reflection on this type. What kind of reflection do we want to do? Well, all the declared constructors. That's the kind we want to do.
Right.
There's other things you can put here, and including all of them. But in this case, it was smart enough to know all we're trying to do is to get the declared constructors. So please make that possible. And then we want to do it for these, these methods. Well, these are the constructors, so it's a little redundant, but whatever. Either way, this is exactly right size. It's not more or not less than we need to make this particular application work. So good.
It's a lot of brackets. I have my doubts, but let's run.
Okay.
Let's see how it goes.
Build, please work.
Is it time for another random fact?
Fact. Yes, OK. So.
That is one of my favorite ones. So GraalVM, as a compiler, is itself written in Java. So the very compiler, the thing that is usually written in things like C, C++, is written in Java. And here you might, if you think about it for a bit, you might think, OK, it's in Java, and we know that Java has a bit of a warm-up curve, right? So how does it work for runtime when I actually need to compile my code on the go? And the best part is that we got our compiler written in Java, and then we used native image, so the one we are using right now, leveraging itself the GraalVM compiler, and we compiled it to native to produce a native executable. So we kind of compiled GraalVM with GraalVM to make it faster, and that is how fascinating the project is. What?
Is there something you've been hiding from me? Is this real? This is
know.
awesome. Wait.
We can explore it maybe after the session, see what's up with that. But my point is, look at that 91.4%, that's all Java.
Oh, yeah, the Java's good too, I suppose. Look at that.
I suppose
Nice.
it's good, yes. Okay, but we run our app.
So there's our app. It worked. It's fine. Okay, good stuff. Predictably.
So we got the config out of the agent. Amazing. We didn't need to write the JSON ourselves. It all just works.
Yeah.
Perfect.
Okay, good. So now, we've established that there's JSON that you can ship in your artifact, and it can be on the class path as well. And that's great if the libraries on the class path ship the relevant configuration. For the particular scenarios where they're using something very dynamic and they need the configuration, then everything will work just fine. But what if, for whatever reason, you're using a library that hasn't as yet been updated to reflect the state of 2023, where we need this stuff, right? Okay.
But let's look at the cool kits first, and let's look at some of the libraries that already ship config for native image. So one of such cool kits is H2. And here, if you go to GitHub and look at their source, and look for reflect config JSON, we will find there this amazing config that H2 ships within the library itself. So if you want to use GraalVM with H2 on native image, it will just work. Because they're cool like that, living in 2023, just works with native image. Amazing.
Right. And they're not alone.
They're not alone.
There are a number of different libraries.
I think it's over 150. So, I mean, a valid question that I get sometimes is that what if I want to build my app as a native image, but I have several dependencies? Is there a way for me to know if it will work or not without actually building the app? So is there a place I can go and just see what works out of the box? So on our website, you can see this page with all the libraries and frameworks that we at least know work well with native image, are tests that work consistently out of the box.
Now, what about if it's not provided by the libraries?
It's a bit sad, but there is this centralized place that we created on GitHub, and that's called GraalVM Reachability Metadata Repo. So it's a centralized place where GraalVM native image users, but also framework and library authors can contribute, share, and reuse configuration for native image so that other people don't have to. So maybe once you figure this out, why not share this with the community so other people don't have to go through all of that by themselves? And we have many contributions from the community and from the Sprint team themselves in particular as well. So thanks for that. And the best part is that this is integrated with GraalVM's Maven and Gradle plugins. So from our plugins, you can give access to the repo. And what they will do is that when you build your application, they will look at your dependencies, and they will pull the config automatically from this place. So you don't even need to know or configure versions, libraries, etc. And Sprint itself is actually using this by default, right?
It's by default. So you have to do nothing. It's just nice to know that it's there, right?
And have to do nothing. Amazing.
Okay. So now, this is like the normal situation, the normal sort of experience of people using GraalVM. What's interesting here is the new Spring Boot 3 AOT engine, right? The idea is that we've got this configuration. Wouldn't it be great if we could just have that informed by our application itself? Wouldn't it be great if there's some sort of meta model that allowed the framework to, well situated though it is, as sort of the orchestrator of all your business logic and components, wouldn't it be great if it could do some of that work for you rather than having to write these config files? So case in point, we're doing reflection. There's actually a much easier way to solve this reflection situation than writing JSON. So we can do register for reflection binding album.class, right? That's an annotation that's in Spring Boot. And it's just for the very common case of, hey, I'm doing something that does reflection, but that is not doing reflection in the context of a Spring component. So for example, if you have a controller handler method that returns an object and you want to serialize that, Spring will see that. It sees that you've got a controller, and it's automatically going to make the return value from those controller handler methods serializable. It's going to register hints for serialization. But if you're doing reflection directly on a class, without some involvement with Spring, then of course you need to account for that, right? So this annotation is just for that one specific scenario, right? So you don't need to worry about reflection a lot of times, but sometimes you do. And you could either write the reflect config or just use this annotation that we just did. So this, you can delete that, and it's pretty powerful. Now, if you wanted a little bit more power,
Should we compile this, or do you want to compile the next one?
We're running low.
Yeah,
We'll do a twofer here.
You can just trust us that this will work.
Right. Well, I got rid of the reflect config, so we'll do that. There's another way you could also inform Spring of like the kind of dynamic hints that you want, right? You could write a hints class, right? And this is a runtime hints registrar, and it's just an object that has a callback wherein you're given a reference to something called a runtime hints that you can use to programmatically register the kind of config you want. So
you want to hint native image about those dynamic features that you're using in your app, right? Those are the hints, what the hints are for.
Right. So we've got that resource config, and we've got that annotation for reflection config. But also you could do reflection here. I can do the annotation, or I could do it here, right? Register type. And here you have a lot more flexibility, in fact. So I could say, I want to, what kind of visibility do I want? Do I want this or that or whatever, or just give them all, right?
I also think it's very nice that you have one centralized place where you're doing all this config, right? So resources, reflection doesn't matter, right?
Exactly. So let's use this hints class. We're going to bring it in like that, okay? Now let's rebuild.
Showtime.
Showtime. Here we go. And we're off. Did you know that GraalVM is a polyglot runtime as well? It's an open JDK distribution that has some extra features beyond the native image compiler. In fact, beyond just the regular just-in-time compiler. One of the things that it's got is this polyglot language runtime, right? That's awesome.
And here at this page, you can see the languages that are kind of implemented by our team, so official, but also on the experiments, you see the languages that are implemented by the community, because it's fairly easy to implement a language on GraalVM because we have this truffle implementation framework, right? So you can go ahead and write an interpreter for your language in Java, and then GraalVM at runtime will take it and provide a high-performance implementation for it. And here we are looking at some fun. Can we go down to the community implementations? So here are some very fun languages. I see 2 brainfuck implementations over there. And it's not on the list, but there exists also Truffle PHP, which is an implementation of one of Josh's favorite languages. And the fun fact about it is that that PHP implementation of GraalVM was written by a student in his free time in 6 months. So if you always wanted to write your own language implementation, GraalVM could be a nice and easy way to do it. What's up?
It worked.
Amazing.
But I forgot to delete the resource config file, so we only know that half of it worked, but don't worry.
All that talking.
I'll rerun it. It'll be fine. Moving on. So we've got hints, and that's like the end of the intermediate stage, friends. That is that runtime hints registrar, that might be as much as most of you need for most situations, if you need it at all. The thing is, that was done sort of absent any context about your Spring application, right? Remember, you're running in an application context. The application context has beans. The application context itself has a lifecycle, and that's kind of interesting. So I want to just take a brief tangent to talk about the lifecycle of a Spring application and its many beans, okay?
But before we go into that, so that was the end of the intermediate sections. We are happy that you're all still here, but then it gets even trickier and more complicated, and you're not expected to understand this, as we said before.
You're not expected.
The hardcore
It's not going to be on the test.
Yeah.
Okay? But if you want to know, now you do. Okay, so there we go. This is, we have to talk about Spring's basic lifecycle. So, and we're going to talk about it broadly in terms of the new stuff and the old stuff. Spring has a application context, which in turn is something called a bean factory. A bean factory contains your beans. We call those objects, right? Just objects. Those objects are managed by the container. If you've used Spring before, then you know that Spring has objects, and it doesn't care how you give it information about those objects. People used to use XML. You can use Java configuration with the @configuration classes. You can use component scanning, where we look in the packages and find objects by their marker annotations, right? All these things all get fed into the Spring bean factory, and they get turned into bean definitions. So once they're bean definitions, they all see each other. They're exactly the same. They're the same kind of component model. Okay? And that's important to remember, is because at the end of the day, Spring doesn't care where the bean definitions came from. Okay? And you can actually participate in different phases of the creation of a bean factory if you want. You can do things at different phases. So one of the things you might do is to create a bean factory post processor, BFPP. Okay? Implement bean factory post processor. Good. So this is an old interface. It's been around forever. And in it, you're given a reference to this thing called a bean factory, right? And so you can actually iterate. You can say for var, let's see, bean name, bean factory.get bean definition names, and I can get the bean definition. And this is a meta model object that describes how, it describes basically the constructors, the properties, the dependencies, all that stuff related to a object in the application context, in the bean factory. And I can then use that bean factory to ask questions like, hey, what's your bean class name? What's your factory bean name? Give me the original root bean definition if you have one. What does it depend on? Give me, constructors, the initialization methods, all that kind of stuff. The scope, in the singleton, session, request, whatever. I can enumerate all that stuff here. In this bean factory post processor. I can even, if I want to, I can use a subclass of this interface called a bean registry or registry, bean definition registry post processor. In this case, you can actually register new bean definitions, right? So this is very low level, but the idea is that you can completely control what objects are present in the application. And this is before we've done any sort of there's no live fire objects at this point. We haven't opened up any network connections. There's no sockets. It's just a meta model about all the objects before they all get created, initialized, and then wired up together, okay? So let's run this. Oh, you got to register this. But remember, this is sort of used in the primordial soup of your application, right? So it's got to be static, right? That's the first thing. Return this, restart. There we go. So you can see I started the application, and it's enumerating all the bean names and the classes if they have them. Sometimes there's supplier methods and all that. But yeah, good. Okay.
Was it here when we wanted to set breakpoint and show people in more detail what's happening with bean definitions?
Well, yeah, you can inspect all that. Good. So yeah, you've got this bean definition here. You can see all the information, whatever. There's a lot, right? Okay, moving on. So we've got this bean definition. You can kind of understand what's happening. There's another interface called a bean post processor. You don't need to get into that, but basically that lets you work on the objects themselves. These bean definitions, however, are super important. Again, we normalize your config. And so what we have at the end of the day is just a bunch of bean definitions. So the real question is, how can we transform the application in such a way that the resulting code, as we ship it into GraalVM, is devoid or free of all the reflection and all the reflective metadata that we have to keep to support that component scanning and all that other stuff on the JVM, right? Because at the end of the day, we have this bean graph. We have this bean graph, this bean definition graph. Why don't we just take that representation and then reify it? Right? We actually do that. And we do it by using something called functional config. And you can see that here. Classes, basics, Spring AOT, for example. Here's an example. Source. This one here, bean factory registration. So when you actually build a native image with GraalVM, we actually start up the Spring application. We take all the data from the configuration classes, the component scanning, the XML, all these other things, get fed into the bean factory, and you get a working, running JVM application that we can then inspect. And we can then take the information about the running application, say, we don't go to the final phase, but we have the bean definitions. We can take all that information and write it out in this code-generated thing. We register things in a functional style, right? And so this is reflection-free. You don't have reflective metadata. There's no scanning on the packages and looking for things looking for methods with annotations on them or anything. We're telling the bean context, we're telling the bean factory, hey, I have a bean called resources. It is going to use this builder thing, which returns an instance of it. So we generate that for you at compile time. That AOT phase is one of the most important things to understand here. Now, I'm not going to get into functional config, but suffice it to say, you can use functional config by yourself. It's been there for 6 years, right? It's not a new thing at all. It's just another more efficient way to register things with Spring. What we're doing here is we're taking it and automatically translating your configurations and your components and all that stuff into functional config. Now, that is happening behind the scenes. What's really powerful here is that you can participate in the AOT lifecycle. You can actually write code that gets to analyze, inspect, and work with beans in this AOT phase. So one way to do that is to write a component of type bean registration AOT processor. So I'm gonna call this my brep for JSON. Okay. So bean registration AOT processor.
So here you're writing your own AOT processor, and most likely this will be helpful for library and framework authors if they want to AOT process that actual library and framework code. But hopefully this is not something that you will ever have to do yourself.
Right. So bean, but I mean, you could if you have like some sort of
for fun.
Yeah. Well. Okay. So there it is. There's this, right? BRAP. We're just going to call this BRAP1 because I'm great with names. Famously great with names. So what I'm going to do is I've got this new component that gets involved only at compile time, when we have started at the bean factory and we've got these bean definitions, but we do not, initialize all the objects, right? We just have the bean graph. And here you get a pointer to all the, this method. If you have 500 beans in the code base, this method gets called 500 times, and you get a reference to this registered bean. Okay? So here I can inspect it. I can say, okay, well, let's get the class, var class equals registered bean dot get bean class. Okay? And I can say, okay, well, what if the bean class is assignable from serializable? Okay? Well, great. If it is, then maybe I want to emit a hint. So here, I'm going to create a JSON config programmatically, just like before, but I'm going to do so by inspecting the objects in the object graph, right? And I can return, if I decide that this is a use case I care about, that I want to contribute something, I can return an AOT contribution, okay? And I can do that using this callback interface here. So context dot get runtime hints. That's the same hints that we saw earlier. And I can say hints.resources or reflection or whatever, but I can do so informed by the current bean. So I can say, okay, well, that type is a serializable type. So I'm going to say hints.serialization, register type, class, and whatever. Maybe I'll just do member category, values, okay? Good.
So this is the way to programmatically create that serialization config for those beans that are serializable.
Right. So here's the get name. There you go. So I'm programmatically registering a serialization hint for all classes in your bean context that are serializable. Silly example, but you get the idea. Imagine writing from a framework perspective. You need to support this use case, and you know it's going to be required. This is actually something that might happen to you. If you're using a session scoped Spring Bean, like a shopping cart that gets recreated for each new HTTP session, that thing has to also be serializable, right? So maybe you want that to happen. Maybe you have a session scoped bean, and you want to make sure that it's serializable. Great. Do this, okay?
One more thing I wanted to mention about this AOT processing. So this helps native image to build a native executable of your application, but this is also helpful because this whole new AOT processing phase of Spring Boot applications will turn your code and transform your code in a way that is reflection-free. And that is good for native image because, well, less configuration, but also even when you run on the JVM, this will be more efficient in terms of performance and memory usage because all those calls are cheaper. So even if you don't want to do native image for some reason, even on the JVM, it will make sense for you to do this processing.
Yeah, you can actually you can run this generated optimized code on the JVM, right? So let's see. So service, whatever, cart, implements serializable. Okay. Whatever. Okay, it's a very simple example. So you should see this run during compilation. Let's go ahead and try that out. Build. Now, we're going to kind of move on because we're running a little short on time. All right, one last. Do we have one hint we can share?
Yeah. I don't think about the next release.
Oh, wait, this one. This is my last. I love this thing right here, quick. Did you know that GraalVM supports RISC-V? Yeah, I don't care either. Moving on. Down here. Look at this. This is important here, friends. Look at this. Considering it only took around 6 months to add RISC-V support to native images using LLVM backend, the idea to add support for other potential targets, such as WebAssembly, is appealing. That's the most committal language I've ever seen from Oracle. It's just appealing. In fact, adding other architectures will become even more accessible as the LLVM backend will soon emit the native image data section itself. That's a heck of a thing to bury in the last paragraph of the blog, but it's really exciting. Okay.
Just in case you did care about RISC-V, though, this was merged, and this will be available in the next release of GraalVM, or you can get our developer builds if you want to try things out before the release comes up in June. What's?
Well, it's not there yet. It's just a sentence. Let's not build anything yet.
Let's not interpret the sentence.
Right. Oh, I did the.
What happened there?
I think I did the test backwards. Whatever. Moving on. Okay. So.
Get into the really crazy stuff.
Right. So this is JSON, right? This is going to actually contribute JSON configuration, which is great. However, like I said, there's an AOT component model now, right? So you have the opportunity to act on, inspect, and then change or transform the bean graph before it gets sent in. So again, it helps to reiterate, when you do native compile on the, or Gradle, Gradle W native compile, what it's doing is it's compiling all the Java source code into .class files. Then Spring creates, it runs the program. It does Java minus jar, basically. It runs the program, but it doesn't create all the actual objects. It does this all at compile time. It creates a bunch of bean definitions. Then it involves your code. It finds these bean registration AOT processors and other similar interfaces like that. It then passes a pointer to this for each bean. And it gives you a chance to inspect it and to contribute metadata like JSON configuration. And that JSON configuration, along with your source code, or along with some other transform source code, gets fed into the GraalVM native image compiler. So the code that gets sent into the GraalVM native image compiler is made better for the metadata that it got from that AOT phase. Why do I mention this? Because sending out JSON is not the only thing you can do. You can actually also send out new Java code, right? So that's the final possibility here. Hopefully I can...
So previously, Spring was doing this for us, right? Spring generated some code for us. For example, that functional configuration that we mentioned but did not actually show. So what happened there, Spring looked at our configuration and transformed it from the way it's more easy and common to write it into a functional config that has less of a performance impact. But what if you want to programmatically generate code? And this gets really crazy, but this is what hopefully we'll show you now.
I'm not writing this by hand.
We wouldn't do it in 5 minutes, probably, no.
Yeah. So there is, OK, first of all, get in here. OK, so this is another type. This is another bean registration AOT processor. I'll register that up here just like I did the very first one as a bean which is statically scoped, right? Or, OK, like that. Good. And this thing,
as you can see, very trivial code, nothing complicated happening there.
We're looking for a bean of type simple service, OK, which is this thing I've got here. It's a bean that will get started and run at runtime. But what I want to do is, at compile time, I want to write some code that acts on this instance, OK? And so I've got this same bean registration AOT processor. I have a test. I'm saying if this class is assignable from, oh, maybe that's what I did. I did it the other way around. If this class is assignable from this one, if it's not, then return null. That means you don't care. Just move on. If it is, however, then you can use this other thing that we didn't look at last time. We looked at the
context?
Yeah. So now we can get the generated classes, and I can create a feature. The feature is basically just a class. It's saying create a new class that will be involved in the initialization of the code, OK? And we're using an API here from Square. How many of you know Square Java Poet, right? This is an API you can use for programmatically generating Java code.
How cool is that?
Right. And it's a builder. So we actually use it in the Spring code here now. And this is not, it takes a minute to squint at it and kind of understand what's happening. But basically, we're building a method called code generation for the win. It's public static. We're taking a parameter of type registered bean and another one of type simple service. We named the variable for the parameter called registered bean. The other one's called simple service. And then in the input bean, that's the parameter, we call provide origin, and we create a new Java instant and a new file. And that has literal values for the current time of compilation. So system time, current milli, and here's the path, OK? And then we're just going to add that instance processor to the code. So that's telling Spring, hey, hook up this new method that we just wrote to the initialization of this bean. So now let's go ahead and try that out. OK, this one's for all the marbles. Now,
the last one.
What does this mean for you? Well, it means that we've already done some of the really low-hanging fruit, some of the big things, like making it so that we transform the bean graph into this optimized functional version of the bean graph. That's already there, and there's plenty of opportunities to go forward. There's big changes that, big things are already in store. But the point is, this mechanism is available to you as well. So if you wanted to use this AOT component model to, for example, do code generation for some, I don't know, schema or something like that, maybe you've got some sort of a RPC mechanism or whatever. There's all sorts of interesting opportunities here.
OK, what's up?
So
we see our timestamp.
Right. You see when I ran the program, it said 722Z, OK? So let's run the program again, right?
AOT.
Yep, there it is again, right? 722Z. So I've reified at compile time the time it compiled in the path. That kind of stuff is you're not going to do that, but it's interesting to know you could, right? You have compile time context now that can inform the runtime behavior. And you can see that also in the generated code. That code that we just wrote is here. It's called simple service feature, right? This is the code that was generated by creating that method there. So I'm getting a reference to the simple service. I'm calling provide origin, passing in the runtime and the date and all that. Very, very, yeah, I know. The look on your eyes is indicative of just how awesome this is. I can tell.
How practical.
Yeah.
Okay, so should we summarize this?
You summarize. I want to point people, if you want more time to digest, friends.
So what we want to show you here is that you can build Spring Boot apps that will be compatible with native image, will run on native image, will start fast, use very little memory, and to do so, you would just go to start.spring.io, add one dependency, which is GraalVM native image, the very first one on the list, and that's your path to building such an app that we built today.
Right. And this is an ebook you can get for free. It just requires, it's a sign-up
thing. I read that one. It's very good.
And then there's a video I did 2 hours in depth showing all the stuff that we didn't have time for this time. Friends,
if you didn't have enough today, you can watch 2 more hours of Josh talking about it.
Oh, it's not great. Friends, thank you. Who learned something new? Who had fun? Yeah, some of you are like, okay, that's fine. Thank you so much. Have a great day.
Thank you for coming.
Whew.
Yay.
That was awesome, my friend. We did good.
Yeah.